Hi everyone. I hope you guys are having a good break. I was thinking about you today and I thought I would just make a little video just to play around with a little bit to show you how to solve, just to remind you of a section we did where we're going to be solving some quadratics algebraically, and then I'm going to remind you how to do it with your calculator. All right? So when you have this quadratic inequality, the first thing you want to do is set it equal to 0. Get it equal to 0. So I'm going to subtract 2 from both sides. And then I'm going to add x to both sides. All right. So we rewrote this. So we're trying to find where this quadratic for the x values that will give me an output or a y value that's greater than or equal to 0. We want the x values that will give me y values. We want the x values that will produce positive y values or y equals 0. All right, and so if they ask you to solve this algebraically, then we have to factor, all right? We have to find the x's that's going to make this equal to 0. So I'm going to use AC splits B. So A times C equals 6, and the factors of 6 are 1 and 6 and 2 and 3. I want them to add up to 7, so I'm going to use the 1 and 6. All right, and I'm going to box that off. Again, this is going to help us find the x values that will give us a y value of 0. So it looks like I can factor it out in x. And that'll give me 2x plus 1 left. And then I should be able to get a 2x plus 1 out of the second box. If I factor out a 3, that'll give me 2x plus 1. If you see it twice, write it once. And then write the binomial that's left. So this will help us find the x values that make a y value of 0. All right, that's what this does. So we'll set each binomial equal to 0. And we'll solve for x. So this will give us the x values that will produce a y value of 0. Okay, there we go. So now I'm going to put these on a number line. Okay, ready? So let's see. X is -3 is right here. X is -1/2 is a little bit to the right of it. And because I want the values that are greater than or equal to 0, since these x's make the y value equal to 0, I want to include these to make these closed circles. So I've divided up my number line into 3 intervals. I have from -infinity to -3. So we have to find out whether, when I put an x value in this interval, if it's going to give me a positive or a negative y. We're going to look at -3 to -1/2. And we're going to choose one x value that will tell me if the y values are positive or negative in this interval. And then we're going to choose a y value in this, or an x value in this interval. And that will tell me whether all the y values are positive or negative. So this is what we did with our test values. So I'm going to choose a value in this interval. How about we choose -5? Any value will do. A value between -3 and -1/2. I'm going to choose -1. And then a value in this interval, I always try to choose 0 if I can. So these are what are called our test values. Okay? Now you have a chart. I was playing around with a different problem, but I'll just use this chart. You'll have a chart that will help you, that you can fill in with the intervals and the test values. If I can fold this up. All right, so we're going to go from, on this chart that I'm fixing, because I was using it for a different problem, but it's the only one I have. So I'm filling in on this chart the 3 intervals. We have from -infinity to -3. That's one interval we need to test. This one looks like -3 to -1/2. And this one's going to be our -1/2 to infinity. All right, so the first test value we chose was -5. Now we're just putting these into the factored form of our quadratic. So we've got 2x plus 1 and x plus 3. That's my factored form right there. So if I put -5 into this first interval, I'll get -5 times 2 is -10 plus 1. That's a -9. And then if I put -5 in this interval, we get -5 plus 3 is -2. And then these are being multiplied. So a negative times a negative is a positive. So if you put -5 in here, you're going to get a positive value out. Okay. The other test value we picked was -1. So if I put -1 in here, we'll get -2 plus 1. -2 plus 1 is a negative number. If we put -1 in here, -1 plus 3, that's going to give me +2. And a negative times a positive is a negative. So no matter what this is saying, no matter what value in this interval you choose for x, it's going to give you a positive y value out. This -3 gives you 0. And then no matter what point you pick in here, it doesn't matter if it's -1, -2, if you put that into your function, it's going to give you a negative value out for your y. This -1/2 gives me 0. And now let's put 0 in for our test value. So if we put 0 in for here, it's 0 plus 1, which is positive. If we put 0 in here, that's 0 plus 3, which is positive. And a positive times a positive is a positive. So it doesn't matter what test value. You could have picked 0, 1, 2, 3, 4, 5, 6, 100. It doesn't matter. No matter what you put in there, you're going to get a positive y value out. Okay, so this is where all the y's are positive, this is where all the y's are negative, and this is where all the y's are positive. And we want to know where the y values are greater than or equal to 0, so that's positive. So we want this interval as part of our solution and this interval as part of our solution. So we're looking from -infinity to -3. And we're going to join that with -1/2 to infinity. Now, if they ask you to say, hey, use your calculator to solve this. Well, I went to my original problem. Okay, right here's my original. And all I did is I put the left-hand side into y1 and the right-hand side into y2. And when I hit zoom 6 to graph it, there's my quadratic and there's my line. Now look, we want to know where the quadratic is bigger than the line. Like, where is the quadratic above the line? Now, if you look at your calculator, find a piece of blank maybe so I can put that as background. If you look at your calculator, the intersect key gives you where they are equal, right? If you go, if in doubt, go to calc, hit 5 and 3 enters. Okay, there's my -1/2 right there. So that's x equals -1/2. And to find the other value where they're equal, right? You use your intersect and get it closer to the other value and then hit your enter 3 times. So you can see that they're going to be equal at -3 and at -1/2. So the quadratic is above the line right here. So these are the values to the left of -3. So that's why we got -infinity to -3, and we want to include the -3 because we want to include where they're equal. And then this is where the quadratic is below the line. And then here, starting at x equals 1/2, and then everything to the right of it, everything to the right, that's where the quadratic is also above the line. So that's how you can look at your calculator to check it. Or if they say solve using your calculator, well, you can just do it this way. Okay? So that's one that I wanted to go over. And then the other problems were just problems like what we did in class on Friday. So I thought we could just I just pulled these two right out of my math lab, and I thought we could just go really slow with them. So if they ask you to solve problems using the square root property, you have to get the squared term by itself. So I can see my squared term here, and so I want to get this by itself. So first thing we're going to do is we're going to add 7 to both sides. And then we're going to divide by 5. Okay, so now I have y squared equals 29 over 5. So to undo the square, this is where we take the square root. And then the only thing I said you got to remember is that you can always do the plus and the minus of the square root. So here, let's do the left-hand side first. So the square and the square root are inverse operations. They undo each other, so the y falls out. And then we got to remember the plus and minus in front of the root sign. Now this is a lovely answer, but it's not in simplest form. So let's break up that fraction. And then to rationalize that denominator, to make it simplified, we're going to multiply top and bottom by root 5. All right, so we'll have root 29 times root 5 all over 5. And 29 and 5 are both prime, so root 29 times 5 is going to be root 145. We can't simplify those at all, so we'll just combine them under one big root symbol. And there's your solution for that one. All right, so let's try that again. So I can see I have this big term that's squared. So now I have to get this whole thing by itself, and then I can take the square root of both sides. Okay, so let's subtract the 4. So we'll have 2 times t minus 10 squared equals 14. And then we'll divide by 2, and now that squared term is all by itself. So now we're going to take the square root of both sides. As soon as the squared term's all by itself, we take the square root. So now let's deal with that left-hand side. The square and the square root undo each other. They're inverse operations, so then the t minus 10 just falls out. And then don't forget, when you take the square root, you can have two options that will satisfy that square. I can't simplify that at all, so I'm just going to add 10 to both sides. And it doesn't matter where you add the 10. So you can say 10 plus or minus root 7, or you could say plus or minus root 7 plus 10, or you could split them up. You have 10 plus root 7 or 10 minus root 7. Okay? It just so happens those are simplified. I can't do anything with the radical. All right, so I hope that helps just to kind of refresh what we did in class, solving using the square root property. My Math Lab's open. The other two My Math Lab sections that are open we haven't done yet, but hopefully this will give you a little refresher when you're starting your homework if you need a little refresher. All right, have a good break. You can always send me a message through Remind if you need some help with anything. Otherwise, I will see you a week from today.